Alright, today we are going to be continuing to work with finding the probability of single events. Our objective is the student will be able to understand and apply the concepts of simple probability. The numbers 1 through 20 are written on individual cards, and the deck of cards is shuffled. One card is chosen from the deck. Find the probability of the card being even. Okay. So, first off, we have 20 cards. Okay. Actually, I'm going to write this up here. So, our 20 cards. We need to find the probability of those cards being even. So the probability that they're even. Alright, even. Well, we have 20 cards, and half of those should be even, right? We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Basically, these two columns are even. So there are 10 even numbers out of the 20 possible cards, which gives us a probability of 1/2, or equally likely. Alright, the probability of them being a factor of 24. So the probability of factor of 24. Alright, factors of 24. 24 can be divided by 1, 2, 3, 4, 6, 8, 12, and obviously 24, but 24 is not an option. So I have 1, 2, 3, 4, 5, 6, 7. 7 factors of 24 in my list of 20. That gives me a probability of 7 out of 20. The odds that they are prime. Being prime. Prime means that you can only divide a number by 1 or itself. So, for example, numbers like 3 are prime because you can only divide 3 by 3 and 3 by 1. So, prime numbers, I'm going to go ahead and circle them in this list. Prime numbers here would be 1, 2, 3, 4 is not prime, 5 is, 7's prime, 11 is prime, 13 is prime, and 17 and 19 are prime. So how many prime numbers do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 prime numbers out of 20. Okay. Moving on, we have our last two questions for this example. If a card is taken out of the deck, is it more likely to be odd or even? Well, in our previous example, or part A of this example, we said that there were 10 even cards. The probability of them being even was 10 out of 20, which was equal to 1/2. So you're actually equally likely to be even or odd. There's no advantage. If a 5 is drawn out of the numbers of cards and not replaced, what are the chances of drawing a second card that is divisible by 5? So, divisible by 5. I'm just going to go ahead and quickly write out our list one more time just for reference. Okay, numbers that are divisible by 5. First off, it says if a 5 is drawn, so that means we got rid of 5. And not replaced, again, we took the 5 out, we're not bringing it back. What is the chance of drawing a second card that is divisible by 5? Things that you can divide by 5: 10, 15, and 20. So I have the probability that I can divide it by 5. I have 3 things that I can divide by 5 out of 19 cards, because remember, we didn't bring this 5 back. So we only have 19 possible cards now. Moving on. If 2 dice are rolled, how many possible outcomes are there? Well, there are actually 36 possible outcomes. You could have all of these outcomes. I'll just quickly write them out. Okay, there's all 36 options. Because there are 2 dice, each dice has 6 options, so 6 options for the first dice, 6 options for the second. The total number would be obtained from multiplying them, so that's 36 outcomes. Find the probability of obtaining a total of 5, meaning when you roll the dice and you add the total, how likely are you to get a 5? So, totals that add up to 5. You could have a 1 and 4, you could have a 2 and 3, you could have a 3 and 2, you could have a 4 and 1. After that, everything becomes larger than 5. So you only have 4 out of 36. So the probability of rolling a 5 would be 4 out of the 36, which is going to be equal to 1/9. Now a total of 11. The probability that you would roll an 11. Well, things that add to 11. 5 and 6. 6 and 5. That's it. You're not going to get any more than that, so that's going to be 2 out of the 36, which is going to be 1/18. So you are more likely to get something that has a total of 5 than you are to have something that has a total of 11. A bag contains 10 red balls, 5 blue balls, and 7 green balls. Find the probability of selecting each of these options. So, we have the probability of finding blue. First off, I'm just going to make my list here. I have 10 red, 5 blue, and 7 green. For a total of 22. So, probability of finding a blue ball is going to be 5 out of the 22 total. Probability of finding a red or a blue there are 10 red and 5 blue for a total of 15 out of 22 possibilities. The probability that it's not green. Not green. What did we just find? Things that are not green. We literally just found it in example B. Not green would be things that are red or blue. So again, the probability that they are not green is going to be 15 over 22. The probability that it is blue or green that would come from here. Oh, not blue or green, pardon me. Not blue or green. Things that are not blue or green would be red. The probability that you would find something not blue or green or red is 10 out of 22, which you can reduce to 5 out of 11. In this next problem, if 1 red ball, 2 green balls, and 1 blue ball were taken out and not replaced, find the following. The probability that there's not a red or a blue, the probability that there is a green. To do this, you're going to make your little list, knowing that you took out 1 red, so that's going to leave us with 9. You took out 2 green, so that's going to leave us with 5. And you took out 1 blue, so that's going to leave us with 4. For a total of 18. So the probability of not red or blue would be 5 out of 18. And this is the exact same thing as the probability of green. So again, all right. Lastly, 2 dice and 2 coins are thrown at the same time. Find the probability of the following. So first off, let's just worry about what we just read. I have 2 coins. When I roll 2 coins, I have these options. I have heads, heads, tails, tails, heads, tails, tails, heads. So there's 4 outcomes there. If I have 2 dice, I have all of those options we just talked about in the previous example. I have 1, 1 all the way to 6, 6. Okay, those are all of my options. I'm going to fix this really quick. Okay. So, if I look at this, 2 coins, I have 4 options here. 2 dice, I have 36 options. So for my total number of outcomes, what I do is I take 4 and multiply it by 36. This is going to give me 144 possible outcomes. Okay? So, I'm going to need to know that number when I'm talking about probability of some event. Okay. Now let's look at the first example. Find the probability of the following: 2 heads and a total of 12 on the dice. So first off, let's look at the 2 heads. There's only one time where you roll 2 coins that you can get 2 heads. A total of 12 on the dice, meaning your 2 numbers add up to be 12. There's only one option where the 2 numbers add to be 12. So, for the 2 heads, the probability of 2 heads is going to be 1 out of the 4. The probability that I roll a 12 is going to be 1 out of the 36. And if I want to find the overall probability, that's going to be 1/4 times 1 over 36, which is going to be 1 out of 144. Because only one time will I be able to roll 2 coins, or to flip 2 coins, and to roll 2 dice, and at the same time get 2 heads and 12 as my total. Let's take a look at another example here. Part B. A head, a tail, and a total of 9 on the dice. So we're going to start with the head and the tail. Head and tail, head and tail. There's 2 on the coins. So there's 2 out of the 4 options. A total of 9 on the dice. So things that add to be 9. Things that add to be 9 are going to be 3 and 6, 4 and 5, 5 and 4, 6 and 3. So 4 out of the 36 options. And if I want to find the overall probability, I need to multiply them. 2 over 4 times 4 over 36, which is going to be, pardon me, that's going to be 8 over 144. And if I reduce that number, I can divide both of these by 8 actually, so that's going to be 1 over 18. Okay. Next, two tails. Boom. There's only one option for two tails. It's going to be 1 out of 4. And a total of 3 on the dice. A total of 3. You got 2 choices there. So 2 out of 36. My overall probability, or the probability for both things occurring, is going to be 1/4 times 2 over 36, which is going to be 2 over 144, or 1 out of 72. Part D. What is the most likely outcome? So, what thing could happen the most for flipping 2 coins and for getting a total on your dice? Well, as far as the coins go, things that happen the most would be getting 1 head and 1 tail. Because that happens more than getting 2 heads or getting 2 tails. The dice, to find the total that occurs the most, you're just going to cut this thing in half. Literally, you're going to go up the middle. Okay? Every single one of these pairs adds up to be 7. There are 1, 2, 3, 4, 5, 6 times where you can roll 2 dice and get 7 as your total. So this is the most likely outcome. 1 head, 1 tail for your dice, and a total, or 1 head, 1 tail for your coin, and a total of 7 for your dice.